So today we're going to see about quadratic equations and we are going to discuss in great detail all the topics that are required. So we are going to see the solution for the quadratic equation first of all, and then the relationship between roots and coefficients. This is also known as Vieta's formulas. So after that, we will see the nature of roots, that is to say the possibilities that can arise when you solve a quadratic equation, that when you get a real number, when you get a complex number as a root, and when do we decide that it's a real number or it's a complex number. Then we have transformation of equations. This topic basically focuses on the transformation of equations through different substitutions and how the roots of those new equation will behave corresponding to the previous one. And finally, we will do some solved examples, problems that are of good interest, and that will teach you basically all those four things that we have learned before. So let's get started. So first of all, we'll start with the solution of the quadratic equation. So a quadratic equation in a standard form is written as ax squared plus bx plus c equals to 0. And we will assume for this that a, b, c are basically real numbers. So to solve this equation, we multiply both sides by 4a, which becomes 4a squared x squared plus 4abx plus 4ac equals to 0. And then we simply write this as 2ax plus b whole square. You will notice that this term is 2ax whole square and this term is the 2ab term from this expansion. What is missing is the plus b square. So if a plus b square is already present in this expansion, we must have a minus b square to match it to the upper equation above it, right? Plus 4ac equals to 0. Therefore, 2ax plus b whole square is equals to b square minus 4ac. And if you take the square root, you will get 2ax plus b equals to plus minus root over of b square minus 4ac. Therefore, subtract b from both sides, you will get 2ax equals to minus b plus minus root over b square minus 4ac. And therefore, x should be equal to minus b plus minus root over of b square minus 4ac whole divided by 2a. So this is how we can solve the quadratic equation. Now, for the solution of this quadratic, we assumed ABC and real numbers, and we found the value as I have stated here. Now, we also denote B as the discriminant of the equation, and B is defined as B square minus 4AC, the term that was inside the square root. This is going to prove vital for us in the next steps when we were actually in the section of determining the nature of roots and how the value of this basically determines if we have a real root or if we have a imaginary root. So in terms of b, x can simply be written as minus b plus minus root b by 2a. So this would be the solution for the quadratic equation. We can try one here. So let's say we have the quadratic 2x squared minus 5x minus 3 equals to 0. And we want to solve this quadratic equation. First, compare it with the standard form. You can see that a is 2, b is minus 5, and c is minus 3. Notice that it is important to get this in the form as exactly as this one. So you cannot keep the constant term on the right hand side and stuff like that. So you have to bring everything onto one side, and the right hand side would be equal to 0. And only then can you compare the coefficients of x squared, x, and the constant term and put the values of a and b, c correspondingly. For this, the value then would be minus b, which is minus of minus 5 plus minus root over of b square, which is minus 5 whole square, minus 4 times a times b divided by 2 times a. So if you simplify it, it becomes 5 plus minus. This is 25 and this becomes 4 into 2, 8. 8 into 3 is 24 and the minus and minus becomes plus. So 24 plus 25 is basically 49 and root 49 is 7 divided by 4. So the two roots, let's call them alpha and beta. One is taken by taking the positive sign and another one is obtained by taking the negative sign. If you take the positive sign, it becomes 5 plus 7 12 by 4, which is 3. And the other one, 5 minus 7 by 4, which is minus 2 upon 4, which is minus half. So these are the two values which satisfy our quadratic equation, and they are also known as the two roots of the quadratic equation. Okay, so we are done with the first part here. Now, we are going to discuss about roots and coefficients of a quadratic equation. So, the equation ax square plus bx plus c equals to 0 has two roots. Let's call them alpha and beta. Now, the relationship between roots and this equation can be established, and I will show you how. But first, let me write down the equations. So, the sum of the roots is given by minus b upon a, where a, b, c, everything that I'm going to use here is as per the standard form of the equation. So, the sum of the roots is minus b upon a, and the product of the roots is c upon a. Let this be equation 2. These are also called Vieta's formulas, and they can be generalized to higher degree equations as well. So you can also do it for a cubic, quartic, quintic, and for like any nth degree polynomial. Basically, you can do it for anything. Okay. So how do we get this? So what happens is, if alpha and beta are the roots of this, fundamental theorem of algebra states that every polynomial equation like this, if you have the set of roots, then it can be factorized like this. So you first write the leading coefficient, which is a. The leading coefficient means the coefficient of the leading term. In this case, this is x square. And then we simply write the product of the roots in this form, x minus alpha into x minus beta. So this can always be factorized into this form once we know the roots alpha and beta. For now, we are just denoting it as alpha and beta. We do not need to know the roots specifically. And now, since this is an identity, this is true for all x. Basically, all x belongs to real. Since it's true for all x belongs to real, once you expand this side, this becomes ax square minus of alpha plus beta x plus alpha beta. And now, if you compare the coefficients, you get the desired values. How this is equal to this. Okay, this, so there was a here, also a here, because a was also multiplied with everything. Okay. So once you compare these coefficients, you will get these two equations. These are called the relationship between the roots. And how we can use it, let's see. Let's say we have an equation. Let's take the equation like before, 2x square minus 3x minus 5 equals to 0. Let's say this is some equation. And you have the two roots as alpha and beta. And you are asked to find the value of 1 by alpha plus 1 by beta. Now, this would be troublesome if you were to actually solve using the quadratic formula and then find out the values of each root. That would be a bit lengthy process. But as you know, we can simplify this by taking the LCM and writing this as alpha plus beta pi alpha, right? And you already know that alpha plus beta, according to Vieta's formulas, should be minus b upon a. Now, what is b? B is minus 3. And what is a? A is 2. So this should be 3 by 2. Similarly, alpha into beta, this should be equal to the constant term c by a. So c is minus 5, a is 2. So minus 5 by 2. Plug in the values, you will get 3 by 2 divided by minus 5 by 2. The 2's get cancelled and the answer becomes minus 3 by 5. So this is a much easier way. Once you learn how to use these two equations to your advantage, almost anything involving alpha comma beta can be found out. So any algebraic expression involving alpha and beta can really be found out using only these two equations. So that would be how you use the relationship between the roots and the coefficients. Okay. Now we have the nature of roots. So for the nature of roots, let's discuss the solution first. The solution was x equals to minus b plus minus root over b square minus 4ac whole divided by 2a. This was our solution to the quadratic equation, right? Ax square plus bx plus c equals to 0. Now, I had told earlier that d is the discriminant, which is given by b square minus 4ac. And we are going to create three cases, and those three cases will basically determine whether the roots are real or imaginary. So case 1. The first case is when b is greater than 0. When this happens, what we get are real roots, and also in addition to that, they're distinct. So we get distinct and real roots when d greater than 0 happens. So that is something we need to keep in mind, that real and distinct is only possible when the discriminant is strictly positive. Again, for case 2, let's say d is less than 0. In this case, we get imaginary roots. As you can understand, if since d is inside the square root, if d is negative, then obviously square root of something negative would be an imaginary number. And that is why we do not get any real roots. And imaginary roots always occur in conjugates and pairs. So conjugate pairs. So if a plus ib is a root, then a minus ib will also be a root of the same equation. It has to be true. And this is true only for equations having real coefficients, of course. When ABC becomes complex, things change. Case 3, if d is equal to 0. When this happens, we have real and equal roots. And both the roots are basically equal to minus b upon 2a. Since the d terms become 0, as you can see from this equation, that if the d term becomes 0, then we have minus b by 2 for both the answers. So those are double roots basically. These are called repeated roots, and we will have real and equal roots whenever d is equal to 0. So these are the 3 cases that we need to understand for finding the nature of roots, and there is nothing else. Okay, so now we are done with nature of roots. Let's move on to transformation of equations, and this is a very important one. So say you have an equation x square plus 5x minus 2 equals to 0, and alpha and beta are the roots. So if alpha and beta are the roots of this equation, we want to find an equation whose roots are basically 1 by alpha and 1 by beta. So how do we find a new equation whose roots are 1 by alpha and 1 by beta? So one way is obviously to find out the value of alpha and beta separately by solving this using the quadratic formula, then finding out the value of 1 by alpha and 1 by beta, and then using the fundamental theorem of algebra by writing it as x minus 1 by alpha into x minus 1 by beta, and let this be the required equation. You separate it out, you expand it out, and you find out the quadratic equation that is required. But we are not really going to do that. Otherwise, this topic would have been useless. So in transformation of equations, what we can do is, can you identify the pattern that the roots follow here compared to the pattern that they followed here? So yeah, it's reciprocal. So since this equation is a quadratic in x, if you define a new variable y, which is equals to 1 upon x, and if you put this value inside this equation, the new equation will have roots corresponding to the values of x that you put here. So the new equation will have roots 1 by alpha and 1 by beta, because the values of x are alpha and beta. So this is called transformation of equations. Let me show you how to do this. So when you take the substitution y equals to x, this basically means x equals to 1 by y. We need to find the new polynomial in y. Substitute it, you will get 1 by y square plus 5 into 1 by y minus 2 equals to 0. So when this happens, we have 1 by y square plus 5 by y minus 2 equals to 0, and you multiply y square to get 1 plus 5y minus 2y square equals to 0. And this is our required equation whose roots are basically alpha and beta, 1 by alpha and 1 by beta. So you can see you can now write it in terms of x, 1 plus 5x minus 2x square equals to 0. This equation has roots 1 by alpha and 1 by beta. So you understand what is going on here, right? Okay, so to generalize this, if you have this equation ax square plus bx plus c equals to 0, and its roots are alpha and beta, and you are asked to find a new equation whose roots are some f of alpha and f of beta, where f is a function, then you simply need to make the substitution y is equal to f of x, and then find out x from this by saying x equals to f inverse of y, put in the value a into f inverse y whole squared plus b into f inverse y plus c equals to 0. Write it in the standard form of quadratic equations, and you are done. That equation is a required equation having the roots f of alpha and f of beta. So that would complete transformation of equations. And now actually let's move on to some examples. Okay, so this is the first example we have. Let alpha and beta be the roots of the quadratic equation x square minus 6x minus 2 equals to 0 with alpha greater than beta. This was one of the past JEE advanced problems. I forgot the year, but this was a pretty good problem. And it is given that if an equals to alpha to the power n minus beta to the power n for n greater than equal to 1, and we will assume that n is an integer, then we have to find the value of a10 minus 2a8 by 2a9, and we need to find this value. Okay. So, okay, let's start with this a10 2a8 thing. A10 minus 2a8 by 2a9. So what is a10? A10 is alpha to the power 10 minus beta to the power 10. Remember that alpha and beta are the roots. So first plug in the values just like this. Alpha to the power 8 minus beta to the power 8 divided by 2 times alpha to the power 9 minus beta to the power 9. Now group the alpha terms together and the beta terms together. So this would seem something like this. Alpha to the power 10 minus 2 alpha to the power 8, and then take minus common, beta to the power 10 minus 2 beta to the power 8 divided by 2 whole into alpha to the power 9 minus beta to the power 9. Okay, now let's go on to the next page. So a10 minus 2a8 divided by 2a9 then becomes, we had grouped these terms earlier as you can see here. So you can take alpha to the power 8 common and beta to the power 8 common. So let's do that. Alpha to the power 8 common, alpha square minus 2 minus beta to the power 8 whole into beta square by minus 2 divided by 2 times alpha to the power 9 minus beta to the power 9. Notice that alpha and beta both satisfy this equation, right? And since they satisfy this equation, we can write here that alpha square minus 6 alpha minus 2 equals to 0 holds. And so does beta square minus 6 beta minus 2 equals to 0 holds. You can see from this that alpha square minus 2 is simply than 6 alpha if you take 6 alpha to the other side, and so is beta square minus 2 is 6 beta. So this becomes alpha to the power 8 into 6 alpha minus beta to the power 8 into 6 beta divided by 2 times alpha to the power 9 minus beta to the power 9. Simplify it further. Since this is alpha to the power 9 and since this is beta to the power 9 and 6 is getting common, so you take 6 common and you see alpha to the power 9 minus beta to the power 9 divided by 2 whole into alpha to the power 9 minus beta to the power 9. Cancel them off and the final answer is 3. So you can see like how these questions may look very tough at first, but once you start understanding the concepts behind the roots and how to satisfy the equations, how to do manipulations, they are extremely easy to be fair. Okay, so this completes our first example. Let's go to the next one. This is a relatively simple one. So we are given the equation 4x and whole into x minus 1 equals to 1. And if alpha is a root, we just need to find the other root. How do we do this? First, let's write the equation in the standard form. 4x squared minus 4x minus 1 equals to 0. Now, in this equation, alpha is a root. Let the other root be beta. Okay. So beta and alpha are the roots. From Vieta's relations, we know that alpha plus beta is equals to minus b by a, right? What is b here? B is minus 4. So minus of minus 4 divided by a is 4. This gives us a value of plus 1. And from this equation alone, we can say that beta is nothing but 1 minus alpha. Correct? And once we also have this, you can do this one as well. Alpha into beta should be c by a, which is minus 1 by 4. And well, you can substitute for beta alpha into 1 minus alpha and you will get the same answer, but this is not required. You could have also found out from here that beta is 1 minus 1 upon 4 alpha. Both the answers work. So whatever is given in the multiple choice, you can choose that. But this is how you find the other root given one. Simply use the Vieta's relationships. Okay, let's move on to the next one. And this is going to be our last example for this video. So this is a good one. We are given this equation x square minus x minus 1 equals to 0. And we need to find this quantity when alpha and beta are the roots of this equation. So let this quantity be given as S. We need to find alpha upon 1 minus alpha whole square plus beta upon 1 minus beta whole square, right? So one thing that comes to mind is obviously let's try and simplify them, and then we can proceed to find whatever we have with whatever data we get from the simplification if something matches our Viera's relations. So it's always useful to write down the Viera's relations first. So alpha plus beta should be equals to minus b upon a. A is always 1 here, so basically it's this minus b. B is also minus 1, so alpha plus beta is 1. Similarly, alpha into beta is minus 1. These are the two relationships. So yeah, okay. From this, we can see that beta is basically 1 minus alpha and alpha is 1 minus beta. So 1 minus alpha can be replaced with beta and 1 minus beta can be replaced with alpha. So this becomes alpha squared by beta squared, this beta squared by alpha squared. And then if you take the LCM, you get alpha to the power 4 plus beta to the power 4. Now use the formula for a square plus b square to write alpha square plus beta square whole square minus 2 alpha square beta square whole divided by alpha square beta squared. Do the distributive law and you should get alpha square plus beta square by alpha beta whole square minus 2, because 2 alpha square beta square divided by alpha square beta square basically cuts off. Okay, so then S is equal to, as we have done in the previous page, alpha square plus beta square divided by alpha beta whole square minus 2. Now, remember that alpha into beta is minus 1. So let's put it. This becomes, since minus 1 whole square is 1 itself, this only becomes alpha square plus beta square whole square minus 2. And again, apply the same formula to get alpha plus beta whole squared minus 2 alpha beta whole squared minus 2. Now, alpha plus beta was 1 and alpha into beta is minus 1, which means this one is 1 and this one is minus 1. So what do we get? 1 plus 2, 3 squared. So 3 squared minus 2, which is 9 minus 2, and the answer is 7. So the value of this expression is basically 7. And you can understand how this relationship between roots helps us a lot. We could have done it also in another way by taking the substitution y is equals to x divided by 1 minus x. Because in that way, the new equation y will have the roots alpha by 1 minus alpha and beta by 1 minus beta. And in that new equation, we simply need to find minus b by a again, which is the sum of the roots. We need the sum of these roots, right? So it can also be done by that. But okay, this one was also a better method, I guess. This would have been a bit longer, but then again, when you have cubic equations and quadratic equations given and such terms are given, it won't be very easy then to find it using this way. And then only the transformation of equation thing will work. Okay. So that would conclude our video here. So I'll have more examples and more concepts. Actually, everything else is covered here, but we'll come back with more examples actually from past year papers and some interesting problems and stuff. So let me know in the comment section how you like this video. So thank you and do subscribe to the channel.